comic relief when in the early 1950s, two American physiologists named Azarinsky and Kleitman discovered what has come to be known as REM sleep, rapid eye movement sleep. They used a new method, a method that wasn't available in Freud's day, called the electroencephalograph, EEG. And this is a technology which you place electrodes on the scalp of the research subject, which records through the cranium the electrical activity going on in the brain, the level of electrical activity, of brain arousal. And as Azarinsky and Kleitman predicted, that if you measure the brain by this method as it goes to sleep, its level of arousal should decline as measured by the EEG. So what you see on this sort of cartoon here, this axis is the level of brain arousal from wakefulness going to lower and lower levels of brain activation. And this axis here is time. So we're looking at 8 hours of time here. And what Azarinsky and Kleitman observed was exactly what they predicted, that as you fall asleep, so your level of brain arousal declines. What was surprising, though, the wonderful thing about science is that you don't only find your Easter eggs where you had hidden them beforehand, you get surprises. The surprise was that 90 minutes later, the brain reactivates itself and then goes down back into that quiescent state and then reactivates itself and does this in regular, roughly 90-minute cycles. So what was this all about? You know, it's a paradox, and they originally called it paradoxical sleep before it was renamed REM sleep. The paradox being you're asleep in a state of repose and quiescence, and yet your brain becomes almost as activated as it is when you're awake. This led them to the hypothesis that perhaps this paradoxical arousal of the brain was the physiological equivalent of the psychological paradox that during the unconsciousness of sleep, you have these moments of consciousness where, despite the fact that you're asleep, you suddenly start experiencing something, and that is the dream. This paradoxical punctuation of the unconsciousness of sleep with the conscious experience of dreams, they hypothesized might be the subjective correlate of the objective phenomenon they just discovered, namely this paradoxical brain arousal. So that led to a further experiment done by not Azarinsky and Kleitman, but the unfortunately named Dement and Kleitman. They predicted that if you wake people up during REM sleep and ask them if they're dreaming, as opposed to wake them up during non-REM sleep, during REM sleep, you will get dream reports, and during non-REM sleep, you will not. And that's exactly what they found. In their mid-1950s paper, they reported that approximately 90% of awakenings from REM sleep produce dream reports, and less than 10% of awakenings from non-REM sleep. And that's about as close to a perfect correlation as you could hope for, given the nature of the phenomenon we're talking about. Subjective first-person reports from waking people up, you know, in the middle of the night, and dreams are, of course, infamously forgettable. So that was really a striking confirmation of the prediction that flowed from their hypothesis that REM sleep was the objective equivalent of the subjective state of dreaming. Now, this was great because now we had something objective. Remember, psychiatry was dominated by psychoanalysis. Psychoanalysis was based on this free association method and fundamentally on Freud's findings about dreams. So at last, we had the possibility to be able to get out of that corner. And now that we had this objective physiological phenomenon of REM sleep, we could get a proper handle on what really drives dreams. This was made much easier by virtue of the fact that it's not only human beings who have REM sleep, all mammals do. And why that was important is because the standard way of going about determining which part of the brain is generating a particular function is to lesion, that is to say, to experimentally damage the different parts of the brain and see which part, when damaged, leads to a loss of the function at issue. So a chap named Michel Jouvet led the charge using cats. What I have on the screen now is a human brain, but human brain is sort of shockingly similar in its anatomy to a cat brain. And perhaps why Jouvet focused on cats was because they sleep so much. And what he did was really quite horrible. He sliced through the cat brain, progressively making deeper and deeper cuts to see at what point do the poor cats stop displaying REM sleep. And the surprise in this instance was eventually Jouvet made a cut here, separating the brain stem from the whole of the forebrain. The forebrain, including the cortex, is the organ of the mind. And remember what Freud was saying, that dreams are driven by these deep-seated desires and wishes and wants and so on. These are clearly mental forces. But when Jouvet made the cut here, effectively disconnecting the organ of the mind from all that remained, the brain stem, which is a very primitive structure, which was considered to be entirely mindless, sort of responsible for orchestration of bodily functions and reflexes. REM sleep continued in these cats, even though the forebrain as a whole had been disconnected. And it was only when Jouvet cut right down here to the structure which is known as the pons, it was only when he reached that level that REM sleep stopped in these cats. And so that showed that whatever it is that drives dreams, it's occurring at this level. Jouvet then passed the baton on to his pupil, Alan Hobson, and Hobson was able to identify precisely what it is that's going on in the pons. When we go into REM sleep, there are a group of cells over here in a region called the mesopontine tegmentum. These cells release a neurotransmitter called acetylcholine, which activates the forebrain. And then when we go out of REM sleep, these cells stop firing, and another group of cells, two other nuclei here, which I don't need to go into the details of, they start firing. So when these ones are on, those ones are off. When these ones are on, those ones are off. So what is it that causes REM sleep, dreaming sleep? It's a simple switch, on, off, and it switches on and off every 90 minutes, automatically. In the mindless reflexive part of the brain that we share with all vertebrates. There's fishes have the same structures down here as we do. And so Hobson wasted no time. We've now reached the 70s. Jouvet's findings were the mid-60s, Hobson's were the mid-70s. He wasted no time in pointing out that Freudian dream theory was clearly wrong. This part, the acetylcholine, there's nothing motivational about it. There's nothing emotional about it. There's nothing mental about it. It's just randomly firing neurons in the cortex. The cortex, being the organ of the mind, is now activated. And so you have this chaotic, meaningless, mindless mental activity, conscious experiences, thoughts, memories, and whatnot. Hobson said that all that the cortex can do is join these dots, sort of make some kind of episode out of this random firing. To quote him, he said, it makes the best of a bad job. And that's the dream. So this was called the activation synthesis theory of dreams. These pontine cholinergic, the cells that release acetylcholine, they activate the forebrain, and the forebrain, poor thing, synthesizes all of these inherently meaningless images, experiences into a dream. I say inherently meaningless. It's really important to get this point, that the thing that causes the dream, says Hobson, is this automatic pre-programmed clockwork of the firing of these cholinergic cells, which randomly activates the cortex, and the cortex joins the dots. You can come and look at that just as with an ink blot after the fact. You can look at this random activity, just like with tea leaves. You can say, makes me think of this or that. It suggests the following to me. But that meaning is not inherent in the tea leaves. It's not really there. It's not in the ink blot. You project it onto this otherwise actually intrinsically meaningless, mindless data. So that was Hobson's theory, the activation synthesis theory, and he presented it at a meeting of the American Psychiatric Association in 1977.